This is Nature 9, and we are moving to a third level, a third plateau, in the first phase of a double cycle. And we're schooling ourselves not to keep track of it exclusively in terms of form. It's a very difficult orientation, but it's one that is quite necessary to recalibrating ourselves to be able to learn creatively and naturally at the same time. It's like someone who goes into weightlessness. You have to learn all over again how to posture and how to move in order to get locomotion and get things done. And we're in a very similar kind of situation in the early 21st century, because all of the gravitas of the past, of traditional education and traditional learning, no longer holds. So we're having to recalibrate ourselves, and we're doing it by just participating in the first phase as nature, and we're giving it a 1, 2, 3 resonant quality, and each of those resonant waves is one lunar cycle, 1 month, 4 presentations. So that the first 4 presentations gave us a reassessment of nature on the scale of thousands of years. The next 4 gave us a reassessment of nature on scale of millions of years. And these 4 are on the scale of billions of years. And in all this, it's not nature as form, but nature as process. That the fundamental process is one of energy, and that as energy occurs, it does not necessarily have to have form for it to occur. And this is extremely important to understand. And that energy is a frequency, and that the frequency has a calibration, and that the change within that calibration is literally the amplitude of the process, the current itself. And though we can later on measure that and come to very specific quanta, in nature, qua nature, and in nature itself, there is no discrete units whatsoever. So that its process is one that does not register except in retrospection. And that the retrospection is the only way that one can then assign a measurement and a calibration to it. But that measurement and that calibration need to be informed that this is not just a simple frequency or an energy that has only one massive characteristic, but that it is filled with all the possibilities that there are. It's much like we cannot see them, but this room is filled with electromagnetic waves. And if we had the proper receivers, we would find there are television signals, radio signals, there are cosmic ray signals, there are neutrinos, there are all kinds of actual energy modulation going on all the time. My voice, your ears, your blood, and we'll see that in fact there is a deep complexity that is not just an overlay, but constitutes the very nature of nature itself. We're going to use two books again. We use pairs of books because this is the way that we can gain a perspective and a focus which can be maintained consistently all the way through everything that we need to experience, everything we need to think about, everything that we need to do. And in fact, holds in nature as well. That pairedness is fundamental. The first book is by a woman, Lynn Margulis, called Symbiotic Planet, and came out in 1998. And the other one is The Double Helix, a personal account of the discovery of the structure of DNA by James D. Watson. I recommend this Norton Critical edition of The Double Helix. The editor, Gunther Stent, was associated with Watson for a long time and is quite an excellent scientist. Here's the second edition of Molecular Genetics by Gunther Stent. So he's enormously capable, both as a scientist of some note in his own right and of having known Watson for a very long time. Now, there are wonderful avenues of approach to the double helix, and we'll get back to some of them in just a moment. There are especially ties with the early part of our inquiry, our education. We began with Thoreau and the I Ching, and there are several volumes on DNA and the I Ching. That there are triplet codons in a set of 64 in both the I Ching, the hexagrams, and in DNA as well. And we've talked before about how the presentation that I'm delivering, I'm always leaving it a little bit homey, not to be hokey, but to give it a presentation that doesn't preemptively style what we're doing before we do it. So all of my notes are very much like the notes of these books for beginners. This is DNA for beginners, and they have Einstein for beginners, Freud for beginners. And it is a technique of handwritten notes, and one of the world famous scientific figures who used to work this way was Enrico Fermi, one of the great physicists of the 20th century, and the man who was the first director of the Fermi Lab just outside of Chicago, which is the most avant-garde high-energy physics place in the world today. When the first cyclotrons were being made by E.O. Lawrence in Berkeley, they were the highest energy that anyone could get to, and they were working with, at the time, a bevitron, trying to get to 1 billion electron volts, and that was like a huge step over some of the earlier ones. The Fermi Lab has a tevitron. It works with 1 trillion electron volts, and because of its arrangement, it can go up to 2 TeV, 2 trillion electron volts, which is the current high water mark in the world until CERN's new Large Hadron Collector and Collider comes online in 2007. So that the presentation has a hominess for many reasons, and the main one is to not get preempted into a calibration that we want to unlearn and want to back out of. And sometimes backing out of it is not possible, and we have to let it just evaporate. So the technique of learning here is one of unlearning at the same time of exploring a new learning. And hopefully this pair of strategies will work together and will produce something remarkable in genetics. And that is that when you have a dominant and a recessive trait, and you put them together in a fertile generation, there is always a 3-to-1 ratio that comes out. Always. In other words, there is a quaternary, and 3 corners of that quaternary, 3 items in that 4 will always be dominant, and 1 of them will always be recessive. The man who explored this in the 19th century was Mendel, Gregor Mendel, and it was an extraordinary thing for him at the time to discover that there is a very curious thing, that when you take that progeny of the 2nd generation and you cross them, what comes out is an amazing distribution. The distribution is, and this is from Watson's first edition of The Molecular Biology of the Gene, written in 1964 and published in early 1965, and it was a hallmark text at the time. The double helix is known all over the world, and when it was written in 1962, it brought international fame to Watson. And in 1965, the molecular biology of the gene began a whole new resonance to the importance of James D. Watson. He would go on, and we'll get back to Mendel in just one moment, he would go on to do a number of editions of the molecular biology of the gene. For instance, this first edition I'm going to allude to was 1965, and by 1970 he had to do a second edition to it. And you can see that the first and second editions, certainly there's some improvement to it, and then all of a sudden the third and then the fourth edition became massive, utterly massive in development of all the complexities of molecular biology of the gene, now residing in almost 1,200 pages. And in 2003, a fifth edition of Molecular Biology of the Gene came out, and I'm sorry I haven't been able to afford a copy yet. But Watson has been consistent all the way through since the 1953, today is the 50th anniversary of that, 51st anniversary of that, all the way from the early 50s to the first decade of the 21st century, he has been consistently there. In fact, when he started under Salvador Luria in the 1940s, there were very few people in the world who had any confidence that one could go beyond what classic genetics founded on Gregor Mendel in the 19th century was able to deliver. And it is James D. Watson who is the great synthesizing figure in terms of developing for almost 60 years individually as a scientist, and also developing the scientific community in order to amplify that work and the interface with the public at large in order to involve them in the amplification And all of this is a very, very great achievement. Mendel's experiment, where he found that the dominant is always 3 and the recessive is always 1, so that the ratio is 3 to 1. This is a fundamental ratio in reality. The meaning of these results became clear when Mendel made genetic crosses between the F1 offspring. These crosses gave the most important result that the recessive trait reappeared in approximately 25% of the progeny, whereas the dominant trait appeared in 75% of them. For each of the 7 traits, he followed the ratio in F2 of dominant to recessive traits, and it was always approximately 3 to 1. When these experiments were carried to a third F3 progeny generation, all the F2Ps with recessive traits bred true, produced progeny with the recessive traits. Those with dominant traits fell into 2 groups. 1/3 bred true, produced only progeny with the dominant trait. The remaining 2/3 again produced mixed progeny in a 3 to 1 ratio of dominant to recessive. So that Mendel correctly interpreted this. This is Watson. Mendel correctly interpreted his results as follows. The various traits are controlled by pairs of factors, not by a factor, by pairs of factors, and we call those factors today genes. So that genes, as forms, as organic biological forms for all forms of life, are pair carriers. So in order to understand the phenomena in its reality, we need to carry a kind of a visual, bifocal quality all the way through consistently. If we blind ourselves in one aspect out of the pair, we will skew. And because we will be seeing clearly in terms of that aspect, we will never know that we are seeing in a skew that increases. And this is built-in ignorance. And to trust in skewed ignorance in this way actually is one of the fatal flaws in civilization. And all civilizations of the past largely began their failure because the consistent misstructuring of further developments was on shaky ground. So our education is very cognizant of this. Now this fact that there are pairs of factors, genes, and that the pairs of factors have a gender quality to them. They have a male or a female quality to them. Not that they're men or women, but they have definitely this kind of symbiotic interchange, and it's this symbiotic interchange that allows for the carrying of the life forms to develop fertily, not just in the sense of being able to have more offspring, but to have offspring that evolve. That evolution is carried in this way. And we'll see with the work of Lynn Margulis that this sexual gendering pairing occurs even before there are organic cells that have nucleuses. That it goes back to the bacteria, and that bacteria have sex. before there's anything like a membraned nucleus to a cell. And this is a very astonishing fact. It means that life, when it first occurs in non-oxygen milieu, because it is only cells with a nucleus membrane that are able to not be poisoned by oxygen and to use it to help to convert certain molecular structures like sugars into energy and not be electrocuted by the oxygen molecules, which otherwise would kill the organism. Mendel's discovery that there are pairs of factors we now call genes is called the Principle of Independent Segregation, and it's also called Mendel's first law. There is also a second law, and the second law is the phenomenon of independent assortment. Now, the first law, that of independent segregation, was found by following a single factor through several generations of crossbreeding. Mendel then methodically put in a pair of factors. What happens if you do the same thing, the same experiment, the same generations with two factors? The two factors that he used, because he used peas, he used round and wrinkled, yellow and green. And then he ran his experiments again. This was in the monastic gardens, and he just patiently and methodically recorded every aspect to it. And Watson, again, 1964-65, says, again, Mendel found he could interpret the results by the postulate of genes, paired factor carriers. Now we have a pair of pair factor carriers, and this is what turns out. If he assumed that during sex cell formation, each gene pair was independently transmitted to the sex cell, to the gamete, that each gene is a pair, and that when you have a pair of pairs, you have a structure that comes out that is universal. This interpretation is shown in figure 1.9. Any one gamete contains only one type of inherited factor from each gene pair. Thus, the gametes produced by an F1 will have the composition of round yellow, round with the smooth, the green round, and the green smooth, but you will never have the pairing of the recessive traits. Furthermore, in this example, all four possible gametes are produced with equal frequency. There is no tendency of the genes arising from one parent to stay together. There is, let's read it again, there is no tendency of the genes arising from one parent to stay together. So that one is not dealing with a static phenomenon that depends upon its stubborn remaining what it is to participate in life. It needs to open itself up to exchange. Otherwise, it is not able to continue itself at all. And we'll see with the work of Lynn Margulis that all of this is established 4 billion years ago on this planet. And that since the universe is about 14 billion years old. It means that wherever life has evolved, this is the way in which it will have happened. And so we're dealing with a rather universal phenomenon here. And part of what we can draw out of it, tease out of it already for ourselves, is that the exchange, participation of the pairing of pairs leads eventually to the capacity for differentiation on a big transform level. And that one of the dimensions that comes out of that then is consciousness. So that the very way in which life happens in its pairedness and the pairs of pairs that don't segregate and keep themselves but exchange and mix in all the varieties that are possible, and that all those varieties that are possible form a matrix which is understandable because it carries a signature ratioing all the way through. So there is no tendency of the genes from one parent to stay together. As a result, the F2 progeny phenotypes appear in the ratio 9 round yellow, 3 round green, 3 wrinkled yellow, and 1 wrinkled green. This phenomenon of independent assortment is frequently called Mendel's second law. So that if you add them up, the 9, the 3, the 1, that's 16. A 4 by 4 matrix. When you have a matrix in math, any column of that matrix, the first 4, the second 4, the third 4, the fourth 4, any column, can act as an algorithmic determiner of a frequency, and any level, the top row, the second row, the third row, the bottom fourth row, can also act this way, so that one has the ability to explore a matrix of 4 by 4, which is a pair of pairs, in a field of 16 possible distributed ways through 4 plus 4 through an 8-fold examination, so that you have a 8-fold perspective, an angle of vision that is possible in a matrix of 16, which is generated by a simple pair of pairs. And one can express very simply, a pair of pairs is 2 squared. So that we're discovering now that nature, as an energy that has a sea of change, not so much obeys laws, but exhibits again and again when it comes into existence, when it comes into form, that form has a definite structure. A structure which is recognizable, a structure which is repeatable, and later on we will find it's a structure that bears 2 highly differential qualities. It's able to be criticized, so that critical examination of a form will lead to its improvement, and it's able to be analyzed as well, so that an analytic can be applied and it can be improved in that mode as well. The critical improvement differentially of forms is called art, and the analytic improvability of forms is called science. So that we have art and science as further capacities, expansions of what we're going to discover is the ritual forms of existence and the symbol forms of the mind. And that one can examine in terms of criticality or an analytic both the forms of ritual existence and the forms of symbolic thought. They're both amenable to both those processes, those expansions. But they are in themselves available to be inspected in terms of themselves. We will see that when ritual forms of existence come out of nature, when they emerge and they cinch themselves into stability, the flow that is there in apparentness in nature shifts to an interlock. It's called polarity. So that you have things that become polarized and become stable and poundable, and there, in ways in which we traditionally would say, well, yes, they exist now, they're there, because the structure has become polarized. But all polarities have the ability to be taken back into the natural energy and to re-emerge and come out not polarized, but come out in complementarities. The natural way in which complementarities comes out is through exchange. And we'll see that the earliest forms of culture are actually very large, traditional forms of the process of mythic experience, and that what keeps it fluid and healthy and in tune with nature is the ability to exchange, to give to each other. Not to barter to get ahead, not to buy and sell to get richer, but that it is a process where experience exhibits, not just requires, but exhibits its health, because exchanges of all types are able to happen in terms of the entirety of the matrix. And one of the things that Lynn Margulis is famous for is her work at the University of Massachusetts in Amherst, Emily Dickinson's hometown. And in her book, Symbiotic Planet, she begins every chapter with a quotation from some of Emily Dickinson's poems. Very, very wonderful touch. Allied with the symbiotic planet is also her development of the relationship to the notion of Gaia, G-A-I-A. Gaia is very succinctly that the entire planet is a life form. The entire planet is not just alive, but is a life form. And that in order to understand it, one has to understand its wholeness, its completeness. So that the matrix of understanding the earth in Gaia is a matrix that would include all of the species that are extant, all of the living species that are extant, and they number somewhere between 7 or 8 or 9 million species. So that one can see that the development of 21st century science in a very realistic way is now an expansion over the 150 years ago of Gregor Mendel, and in the expansion, although there are characteristics which are still operative, and one can see the ancestral forerunner, it has expanded differentially to scales that would have been unbelievable even 50 years ago, and they were not believed. The first writings on the symbiosis as the essential quality of evolution were done in Russia and they were totally ignored. The first American to wrote on it in the 1920s. It was so ridiculed that he had to leave his East Coast university and go to the University of Colorado in Denver, where he quietly served out many decades as just a very quiet teacher and didn't ever raise his issue again. What brought the symbiosis back was, as Lynn Margulis says, is NASA. Because when you go into space and you see the Earth whole, there's no doubt is a living thing. It is alive. You can't miss it. It's not rocks that have living things on it. The planet is alive. And what we're looking at in this education is to understand that the whole star system is alive. The entire star system is alive. We've talked about how the orbits of planets are ellipses. And you need to know that the ellipses also have periodic tilts that carry, and that's called precession. And that while all the planets and all the moons and all the asteroids and everything, even the sun itself, has a precession built into its elliptical orbiting, what is very little understood is that the elliptical orbits are related to each other. For instance, the elliptical orbit of the precession of Jupiter is in perfect alignment with that of Uranus, and that they braid together. That the precession of the orbits of Jupiter and Uranus, though they're separated by more than 1 billion miles of space, they work together. They braid together. They're in a consonance. And we're beginning to understand, and we can carry what we're going to be learning all the way through to finally coming to understand that it is not just that the Earth is alive as a single being, but that every star system is also a being. And that we are definitely related in the sense that we are symbiotic. Just as there are billions of bacteria that live within us, there are billions of us that live within the star system. And that while the Earth as a symbiotic being has only been recognized now for just a generation, no one yet, except here, has been talking about recognizing the star system as a living being, and that our learning is a learning that the environment of a star system is the interstellar population. Within 50 light years of our star, there are more than 10 million star systems. Our galaxy has 2 trillion, and there are trillions of galaxies. So the cosmos is populated by an enormous array of living life forms that are star systems, and we are needing to just come up to where we're mature enough to know that we inhabit one of them, this one. So we're going to expand the Gaia from the planet to the whole star system, and that's why our learning is called interstellar learning. Let's take a break. We're coming back to Nature 9, and we're understanding that this is a very grand project. It's an adventure. It's the largest adventure our species has ever undertaken, and we're the pioneers. This is on a scale in evolution equal to when our first ancestors 2 million years ago walked out of Africa into the rest of the old world. This is not like Columbus discovering America. It's not about something small. This is about an epochal change in life. Whenever a life form becomes mature enough to inhabit naturally and consciously its entire star system, that species then becomes mature in terms of the cosmic scale. That's a whole different thing. It's not dawn yet for the stellar civilization. It's still maybe 2:30 in the morning. But nevertheless, there are a lot of reasons to keep busy and keep working at it. When I began this 40 years ago, there was a lot of science fiction that had been written about different aspects of this sort of thing, but no one had ever done the necessary thing, which was to find a way to learn a completely new scale and to unlearn all of the old scalings that needed to fall off at the very same time. And to do it not just within one lifetime, but to do it within a succinct cycle of something like 2 years. But this cycle also, because of its nature of being truly paired, is capable of having exponentials of that pair so that you could do this cycle as many times as you wish, and each time it will carry a resonant expansion that is actually ratioable. It's provincial to say that your intelligence will expand 10% each time, but it gives you some idea. So that once you will have done it a couple of times in your own way and in your own pace, there will be an appreciable expansion, because what is brought out is not only reaching back and recontacting nature as a process, so that its mysterious fertility and integral capacities emerge better and better, but that the conscious cycle also carries its ability to see and to transform, to critically improve, and to analytically improve that improvement. All of it works together in concert. And more you will discover that it works on any level. One at a time, alone, two people together, a group, or groups of any size, including the entire planet or the entire star system as a whole. And there will come a time in a couple of hundred years where it will be just normal and natural, just a part of things. Let's come back to Watson, James D. Watson, and Lynn Margulis, our pair of books, our pair of people, and the ancient wisdom tradition always moved from person to person. It never moved from idea to idea, and it never moved from fact to fact. It moved from person to person. And this constitutes, in the deepest sense of the word, a lineage, but it's not a lineage. When you move from person to person, what occurs in reality is that there is a set that is established rather than just a sequence. And in that set, there are a finite number of sequences that can be learned, can be selected, can be isolated out temporarily, that can be used then to, as an angle of vision, to explore possibilities of that matrix. let's come back to Watson for just a moment. We're using the Double Helix. We're using the Norton critical edition of it, edited by Gunther Stent. And Watson, to bring a beautiful summation to the discovery of the structure of DNA, Crick and Watson in 1953. For the 50th anniversary, he brought out DNA, The Secret of Life. And you can see here that this frontispiece is a matrix. It's a mosaic of hundreds and hundreds of photographs of people. It's the matrix of humanity. And one of the reasons for this is that Watson worked with an increasing expansion, a set of concerns. One could say that the first concern was with DNA. The second level of concern was with the gene. And we talked about the molecular biology of the gene and how by 2003, a fifth edition has come out of molecular biology of the gene, but by the fifth edition, there are now 5 other authors included with Watson. He has expanded his community. There were only 5 in the 4th edition. There are 6 in the new 5th edition. And the description in the publisher's brochure reads like this: the first edition of Jim Watson's classic textbook, Molecular Biology of the Gene, appeared in 1965. This new edition, written with 5 new authors, has been brought fully up to date and incorporates insights very recently derived from genome sequencing in a variety of organisms. The book is an authoritative and comprehensive survey of the fundamentals of molecular biology, from basic mechanisms to the elaborate role of gene regulation in embryonic development and evolution. Although updated, the 21 chapters of the new edition retain the distinctive and celebrated features of the original work. In other words, there's a morphing resonance that's kept pace in a set. In all the editions of molecular biology of the gene. So there are chapters on the history of genetics, molecular biology, an emphasis throughout on the chemical underpinnings of molecular biology. And when one looks at the very beginning, of course, part 1, even of the 5th edition, 2003, starts with Mendelian view of the world, which we talked about in the first half. And the second, nucleic acids convey genetic information. Right away going that Mendel's pairs held in the genes, so that genes are pairedness, not factors, but carriers of the process of how organic life really occurs and emerges. But that within the genes, the DNA is operating as the nucleic acid, which is really the carrier of the structuring, and how it interfaces is an amazing story. It's not only DNA and the gene that Watson was concerned with, but a further unit called the cell. And so he pioneered, on this textbook, this is the first edition of the molecular biology of the cell, 1983. And he has here a number of authors with him. And the second edition of molecular biology of the cell had a problems book for university teachers because it was being used all over the world. And when the third edition came out, molecular biology of the cell, you can see the enormity of it. It is now almost 1,400 pages, and this third edition is being superseded by yet a fourth edition coming out. This came out in 1994. So Watson was concerned with DNA. Then he was also concerned with the gene, and he was also concerned with the cell, and he was also concerned with the community. That science was carried by a community. It is the community which is the sociocultural carrier of the experience of it, and very, very important. And one of the great adventures was for Watson, who tried, when he left Cambridge University after his great publication with Crick on the structure of the double helix, he tried to go to Caltech for a while. And he went to Caltech because there at Caltech was one of the great intellectual geniuses of that early age, Max Delbrück. Here's his book, Mind from Matter. And here is a book about Delbrook, Thinking About Science, Max Delbrück and the Origins of Molecular Biology. And Delbrook was one of those figures who originally was in physics and was associated especially with the physics community of Niels Bohr, whose Niels Bohr Institute in Copenhagen is one of the great carriers of science on our planet. Caltech also was a great carrier of science in the early 50s and all the way to the present day, but Watson was not at home there. He was understood, but he was understood to be a brash young man. People called him Honest Jim in a derisive sense because he was pushy, because he was just outspoken all the time and very interested in adventures with the ladies, but underneath it all was in love with a particular lady who just didn't ever really respond to him, and he was constantly trying to distract himself from being heartbroken. He had fallen in love with the daughter of Ernst Mayr, who was one of the great biologists at Harvard. Mayer's books, there are 7 or 8 great titles by him. And his daughter Krista was the early love of Jim Watson's life. And when it was not working, to keep himself from being heartbroken, he would go hiking with various scientists and take vacations and go other places, and he just couldn't settle into Caltech. And more he tried to return to Cambridge to see if he could get another year, maybe get a fresh start again, and eventually he was accepted to begin teaching at Harvard. But all the way through, from the first Cambridge years to Caltech, back to Cambridge for a year, then to Harvard, in between all of that, there were constantly forays to a place called the Cold Springs Harbor Laboratory on Long Island. Actually, it's about midway on the north coast of Long Island, and curiously, it's within shouting distance of the birthplace of Walt Whitman. Finally, Watson became the director of the Cold Spring Harbor Laboratory, and it now is a huge series of buildings and one of the centers of science in the world. And this is a book called Houses for Science, written by Jim Watson's wonderful wife of about 35 years, Elizabeth Watson. And in one of his recent books, Watson says, I have been married for 35 years, and she's still a peach of a woman. The DNA the gene, the cell, the community, and one other expansion called the genome, because it is James Watson who, more than anyone else, is responsible for the Human Genome Project. And the Human Genome Project just recently, Nature, the great international scientific magazine that's been read, it comes out every week. It's been read for over 100 years. Here's a little CD. This CD marks the publication of the completed genome sequences of the human and rodent malaria parasites. Complete. So that one can study it with the profound analytic of science and really understand how it works, how it lives, so that not just the treatment of symptoms, but the cure of the disease permanently. And the human genome, the Genomic Revolution, held in New York City, an exhibit at the American Museum of Natural History, May 2001 through January 2002. So that right in the middle of this is the September 11th, 2001 devastation in New York City. The Genomic Revolution. By the year 2020, by 2020, it is highly possible that the average human lifespan will be increased by 50%. Gene therapy will make the most common surgery of today obsolete. We will be able to genetically enhance our capacity for memory, and most violent criminal cases will be decided on the basis of genetic information left at the crime scene. The first draft of the human genome in 2000 contained 30,000 genes, embedded within a 3.2 billion bits of information called DNA, the blueprint for human life. And of course, one sees in the brochure that one is working here with a whole array, and that James D. Watson is like this great conductor who's been working with all of the levels at the same time for over half a century. A really significant human being. He has also consistently supported the development of the scientific community and turned Cold Spring Harbor's laboratory. It had been a little way station for almost a century, just puttering around. And when Watson came in, it energized and it changed. And one finds here, this is the second edition of the first textbook on molecular cloning. This the first edition was published in 1982, and this is the second edition, 1989. And now, if one looks at the Cold Spring Harbor Laboratory Press 2003 offering, there's a new edition, a third edition, Molecular Cloning, a Laboratory Manual. The manual has been a mainstay of molecular biology for nearly 20 years, with an unrivaled reputation for reliability, accuracy, and clarity. It is almost 2,400 pages. So Watson has consistently supported every aspect of the development, and that's why he's included in Nature. And he is also the author with one of his researchers there on the DNA story. So he has tried in every way, all the time, consistently for 5 decades, to present the full array, the full expansion, in fact, the harmonic of the structure of life. And we are very grateful to him for this success. There are two films that form a parenthesis that are interesting to see. The first is a dramatic presentation, The Race for the Double Helix, where James D. Watson is played by Jeff Bloom. And it's Goldblum. It's very interesting. This film is almost unavailable, except Cold Spring Harbor Laboratory Press bought up all the copies, and it's available for $150. But at the risk of being sued by James D. Watson, I've made a copy of this copy of the film, and you can take it home and share it among yourselves and see it. It is the portrayal, dramatically, of the double helix. The second is published by Cold Spring Harbor Laboratory Press. It's called Discovering the Double Helix, and it's an interview with James D. Watson. And this is tracing the history of him. And this was recorded in November 1999, just before the turn of the millennium. Between these two, you get 50 years of James D. Watson, and if you will take the time to get a copy of the Norton Critical Edition of the Double Helix, Gunter Stent has gone through it in a very careful way to give you all of the background necessary, not just to read what Watson wrote, but to read the increasing respect throughout the whole planet that people have had for Watson's achievement. A university educational school, and she spent 4 years there, and when she got into the 8th grade, she couldn't stand it. And she said, it was characteristic humor, the reservoir of possible boyfriends was too small. I wanted to go to a public school where I had a better choice. It was her way of trying to get out of constraints of a situation that was very good for her in a social way. It didn't work for her. And so she lied. She took herself to the public school, to the Hyde Park public school, and she made up all the facts and didn't tell her parents, and her parents kept thinking she was going to the University of Chicago school and she was going to the public high school, and after 8 months they discovered that she had never graduated 8th grade, she was in the 9th grade. And the father was absolutely livid that she would disobey to this extent, making this charade. She's only 13 years old. How dare she? There's no solution to this. You have to go back. Well, you can't go back to the 8th grade. You've been 8 months in the 9th grade. And so finally, she figured out. Because the public school and the university private school were not commensurate. They were half a year apart. She technically should have been in the second half of the 8th grade, and she had been in the first half of the 9th grade. So she said, what happens if foreign students come and they have to transfer from other countries? Well, they're given tests. She said, give me the tests. And so she aced all the tests, and they let her finish the 9th grade. And this is how Lynn Margulis began her career of independence, which has been consistent all the way through. And in one of her interesting books, again, she's done a lot of books with her oldest son, Dorian Sagan. This is a book published by Copernicus Books, an imprint of Springer Verlag from Berlin, and they also have an American office. It's called Slanted Truths. And the very first little essay in it is her wonderful Sunday with J. Robert Oppenheimer. And in the early 1950s, Oppenheimer was castigated by the McCarthy investigations, accused of being a communist. his top security clearance was removed, and he was considered a danger to the American integrity, and he was held at arm's length, and it was a very deep, corrosive experience for a man as refined and as capable as Oppenheimer. It led, again, Lynn Margulis to understand science moves by the community, but it needs to have some figure or figures around which that community can constellate itself, figures that are good at letting the community constellate itself and not being clones of them. And just as James D. Watson and Jane Goodall and Mary Leakey were extraordinarily good at this, Lynn Margulis also. And in her Global Ecology, Towards the Science of the Biosphere, she edits it with two other people. And in it, one finds again and again all of the characteristic qualities of what we saw with Watson, that he worked with a set. He worked with the DNA, with the gene, with the cell, with the community, with the genome. Lynn Margulis has been working with a whole set of characteristics. One of them is the symbiotic nature of life. One is the sexual nature of cellular life going back 4 billion years to the microbes. Another is the Gaia hypothesis of the whole planet being alive. And as we talked about, I'm expanding that here in this education because the whole star system is a living being, has a health on many levels, on all levels. And in her work, increasingly, one understands that it is the level of the bacteria that are the origins of the way in which organic possibilities move from the mineral world into the world of the mobile living creatures, bacteria. And in bacteria, there are kinds of bacterial qualities called phage, and here by Gunter Stent and James D. Watson, Phage and the Origins of Molecular Biology, and here's Max Delbrück. A series of appreciations and essays dedicated to Delbrook. And this was the first edition, 1966. Here is the expanded edition, Cold Spring Harbor Laboratory Press, 1992. Phage, and it reads here, to the expanded edition, like many ideas in molecular biology, the idea for the book Phage and the Origins of Molecular Biology came from Jim Watson. As Jim himself has pointed out, his contributions to biology have depended in part on his strong sense of occasion and keen eye for posterity. In this instance, the execution of the project was left largely in the hands of Gunter Stent, and then it goes on and talks about what we are talking about. There is a consistent pattern here. The consistent pattern is always improvements, expansions, so that it's not a lineage in the sense of sequence, but it is a lineage in the sense of resonance, and that the resonant sets constitute an evolution, a development. And that the key structuring pattern to that activity is like the gene. The gene always carries a pair of factors. And that when you have a pair of genes that come together, each carrying a pair of factors, you have a natural matrix of a square, of a quaternary, of a four. and that the pair of pairs is like 2 squared, and when you get the pair of pairs as a 4 and you square that, it's 16. So that there is a natural sense of structure that reoccurs throughout reality all the time. Nothing comes out simply and statically as that which can be identified as a point. This is an illusion, and to believe it is a delusion. And one of the deepest cutting things is that at the origins of the past civilization, the one that just perished in the 20th century, its origins go back to classical Greece. And in classical Greece, the deciding structural factor was geometry. That a geometry is built up of points which are linked by lines, which when they are there establish a plane which is able to carry a cutout figure like a triangle, a circle, a square, and that plane geometry is very clearly then the way things are, and you will learn this. And all of this is a misunderstanding, a misstatement. Because when one looks at the world's first textbook on plane geometry by Euclid in Alexandria, about 300 BC, the Greek very clearly translates a line is the movement of a point, and a point is a locus of no dimension. A point is a 0-dimension focus, which when it moves, its movement describes what the mind can then say is a line, but in saying it as a line, it is a selected ritual statement and not about nature at all. It's not natural. So that one of the deepest critics of this was Pythagoras. And to Pythagoras, the shift was to take the mind's illusion of geometry being static out of play and to unlearn that and to learn a different way based on music, based on harmonics. And that music and harmonics are based on ratioing. That if you have a line and you put your finger in the middle, the 2 notes that sound on either side of that figure will have a relationship to the string as a whole. However long it is, half that will have a certain relational pitch. And if you put 2 fingers there and divide the string into thirds, you will then have a different, and if you keep doing this, you will build the set of the resonances, and when you get to 8, when you get to an octave, when you get to 4 plus 4, when you get to 2 cubed, 8, you have then what is called in that octave, you have the set which becomes the master set, which when extended in terms of its master set, so that now you not only have one 8-note set, but you put a number of 8-note sets together so that eventually you'll have an instrument after several thousand years of refinement called the piano, which has 11 octaves. Now you have an instrument that can play an enormous variety of musics, of ratios, constellated as a master set of an expansion of the octave to the expansion of all the notes that the human ear can hear comfortably. From the first deepest note on the piano to the highest note on the piano. Yes, there are some sounds, but they're not comfortable lower than that or above that, so that one then has, with the piano, an expansion of the octave to the practical range which our hearing comfortably enjoys. It's quite evident that the I Ching and Thoreau, Mary Leakey, Jane Goodall, James D. Watson, Lynn Margulis have all characteristically in their own ways, and four of them in our own time, have shown again and again that this is the way in which not a learning curve, but the way in which learning occurs. We are setting up, though, an understanding here that the pair is a pair between a phase of process and a phase of form, that's the pair. And that when you pair the pairs, there are two process form that come together, and they make a further four, which is the ecology of consciousness. So that the 8 phases of our education in that 2-year cycle establish the octave in the dimensions of real learning, of true learning, and to extend this then to the star system as a living being puts us in reality into the cosmos, not into a game. What's been wrong with life on this planet has been a vicious game. It's time to grow up. More next week.